Hello everyone. So I had recently posted this image of the Andromeda galaxy on social media and it got quite a bit of attention. And this image also won the Amateur Astrophotography Picture of the Day for October 5, 2023. And a lot of people were asking me about how much detail there is in the full-size image and if I could share some more information about that. Now, the image I posted on social media, of course, was a very low resolution image because Facebook and Instagram always compress the heck out of everything. But this full image is actually 183 megapixels. So this is a humongous image, and this might be one of the sharpest image of the Andromeda galaxy ever taken by any amateur astronomer. At least I haven't found any image so far that was better than this one out there. So I wanted to share a little bit more detail about this image, and I wanted to show you full 100% full-size views of this image, because in the full-size image you can see hundreds of nebulae in the Andromeda galaxy. You can see countless individual stars, countless individual globular clusters in another galaxy. And of course you can see background galaxies behind the Andromeda galaxy through the galaxy. Now, this all sounds ridiculous for an amateur image taken with an 8-inch telescope from a backyard. And I would think it's ridiculous if I wasn't the one who had actually taken this image. So one thing I like to do is pull up a Hubble image, a high-resolution Hubble image of the object that I'm imaging, and try to take a look and see which of those very faint objects from the Hubble image I managed to capture in my own amateur image. Just to get an idea of what it is that I'm looking at in there. And I will also be sharing all of my tips and tricks about how to get amazing images like this with fairly basic equipment. And all the equipment that I use, almost all of it was bought used on the secondhand market for well below market price, and it did not cost as much as you would think from the pictures that I've taken. So here is the plan of videos that I'm planning to release in the next little while. I'll be aiming for one video per week, and that'll give you all the information about best practices that I use, as well as how to process the images in Pixinsight. And yeah, these videos are all free, and hopefully you find something useful. And if you have a better way of doing something that I'm doing in these videos, please post it in the comments below, because I learn as much from you guys as I share on here. So I'm always looking for better ways to do the things that I'm doing right now. So I'm going to give you a full tour of this image, and let's get started. This is the image that I was talking about, the image of Messier 31, the Andromeda galaxy. And as you can see in the 4K video here, this just has tons and tons of actual detail. And you can see all of these red regions along the bottom edge of the galaxy, as well as in the top of the spiral arms. And all of these red regions are regions of hydrogen gas, much like the Orion Nebula or the Eagle Nebula in our own galaxy. And these are all regions of intense star formation. If we look at this one over here, for example, you can see that there are tons of different modules. I guess they would all be considered different nebulae here in the same region. And these are massive. I think something like this one over here would be much, much larger than our Orion Nebula. And the Orion Nebula, if it was in this picture, would look pretty unremarkable next to some of these large regions of gas. In total, there must be hundreds of nebulae all along the border of this galaxy. This is a really bright one, and as you can see in the center, there are a couple of very, very bright stars that are lighting up this nebula that were likely formed from this nebula. And then if we keep moving down, we can see lots of other regions of hydrogen alpha gas. There's another very big one over here. And then as we move up the spiral arms, there are about a dozen or so other regions over here. And of course, this is one of my favorite, absolutely gargantuan region. And in the center, you can see tons of very, very bright young stars. And these stars are all likely hundreds of thousands to millions of times brighter than our sun, because those are individual stars in the Andromeda galaxy that are visible inside this nebula. And again, another very, very large region of just tons and tons of nebulae there, and some more over here. Now, one of my favorite regions of hydrogen alpha gas in this galaxy is this little area over here. I don't know why I like it. It's just the gas is fairly dense around the edges, but then it's creating this bubble on the inside, so we can actually see the stars inside fairly clearly. So I really like this particular nebula here. So those are some of the hydrogen alpha regions, and a lot of them seem to be concentrated along the outer arms of this galaxy. As we move towards the core, where there are the older yellowish stars, it seems, there aren't that many regions of hydrogen alpha gas. Some of them, like the ones up here, appear to be kind of washed out by all the stars near the core. You can see a couple of them over here, but not as many as in the actual outer arms, where a lot of the star birth is taking place. Now, the other thing I'm noticing here is that there is a huge region at the bottom left here of just intense star formation. So if I'm going to zoom in on that, so there it is. So yeah, right there. So you can see all of these intense blue stars. And these are all, again, very, very bright stars, likely, up to 1 million times or more brighter than our sun to be seen so clearly at such cosmic distances. And this is just an absolutely massive cluster of stars. And there are some other clusters like that over on this side as well, just at the very edge of the field of view. Again, fairly new, young, very, very hot and bright stars. And you can see this dust lane going right in front of the core of the galaxy. It's blocking the light coming from behind it, so that's why it looks so dark. And then of course there is this other lane, and these two lanes are quite easily visible from a dark sky in a telescope, and I always try to look for both of these. But again, you can see a lot of structure in the gas over here that you don't see visually or in a lower resolution telescope image. And one of the things I like to do is pull up an image from the Hubble Space Telescope and just look at some of the small structures that I found in my image and see what they actually look like in the image from the Hubble Space Telescope. So I'm going to move my image over to one side, and I will pull up the highest resolution image that I could find from the Hubble Space Telescope. Now this is the image from the Hubble, and it didn't image the entire galaxy. This is a collection of, I think, hundreds or perhaps thousands of tiny little images, because the Hubble's field of view is just so narrow and it has such a high resolution. It can't image the entire galaxy at once like I can, or at least most of the galaxy as I imaged it. So that's why you see this pattern along the border. That's just the shape of the sensor. It looks like a little triangular step. So this is a collage of multiple images from the Hubble. Now, the orientation of this image is fairly similar to the orientation of my image. If you look close to the core over here, you will see this large dark region of gas and dust. And in my image, you can see this same region. It is right over here. It's tilted at a slightly different angle, but the shape is unmistakable. You can see this dark lobe going up. That's the one right over here in the Hubble image. And what we could do is, if we zoom into this region in the Hubble image, you can see just phenomenal amounts of detail, and you can see this little speckled background. Those are all just stars, uncountable number of stars. And I think in this image alone, something like 100 million stars are visible in the Hubble image, but of course it has much higher resolving power than any of us amateurs. and it doesn't deal with the effects of atmospheric turbulence because it's high up in the sky. So that's an advantage that we certainly do not have. But if we zoom in on my image, you can see all the same patterns in the gas and dust there. And what I'm noticing in the Hubble image is this bright pair of two yellow binary stars. I don't know if they're a true binary. They likely are. And I'm not 100% sure if they are actually in the Andromeda galaxy or if these are foreground stars in our own galaxy. But from the looks of it, they are likely in the Andromeda galaxy. They're just extremely bright, an extremely bright pair of stars, very, very large supergiant stars. And these are likely hundreds of thousands of times brighter than our sun if they are in the Andromeda galaxy. And I'm noticing that in my image, I can actually see that yellow pair of stars. You can see the yellowish color of it. And in my image, it's not resolved as two different stars. It just looks like one star because my telescope, of course, does not have the resolution to separate those two stars at such cosmic distances. But in the Hubble image, you can see this beautiful separation. But the color is unmistakable, and it's definitely the same star. And above that star in the Hubble image, I noticed that there is this background galaxy behind the Andromeda galaxy. And of course you can see the spiral kind of shape there, but it's covered by foreground stars, so it's not resolved in the Hubble image either. And when I look at that same place in my own image, right over here, I can see that same galaxy, and of course it's very fuzzy in my image. I don't have the resolution to be able to resolve it either, since the Hubble can't there either. But you can kind of see the shape of this galaxy, and right in front of it you can see this bright blue star. That's the star over here in the Hubble image. And a little bit up and to the right of this galaxy at about the 1 o'clock position, I noticed that there is this fuzzy object that does not look like a star. If you look at the stars in the Hubble image, they all have these 4 spikes around them from the secondary supports of the Hubble secondary mirror, whereas this object does not have any of those spikes around it. So this is not a star. This is actually a large globular cluster in the Andromeda galaxy. And looking at this same region in my own image, right above this galaxy at about the 1 o'clock position, I see the same object. So what I captured over here is actually this globular cluster. And in the Hubble image, you can somewhat resolve some of the stars in that cluster, but not very much. And of course, in my image, you can't resolve any of the stars, but that is definitely unmistakably the same globular cluster. So that's quite something, capturing globular clusters in another galaxy. And so underneath this galaxy and in between these two stars, I see this patch in the Hubble image where my mouse is. And this patch appears to be a distant galaxy in the background of the Andromeda. And if we look at my image in the same area, I don't know if I'll be able to capture it, but so right in between these two stars, right underneath this faint little star, right there, I can see a little patch right there. And that is the exact same galaxy. It's barely visible in both the Hubble image and my image, but just the fact that I can capture such a faint background galaxy that is barely visible in the Hubble image is quite astounding to me, considering I was using a cheap secondhand telescope I'd bought on the used market from my backyard, a Bortle 6 backyard. That is quite remarkable. Now looking down here at this dark patch again, I am noticing that this object over here does not look like a star. It doesn't have those classic spikes that the Hubble secondary supports produce. So this is also a globular cluster, and in my image, it's right over there. So there are these 3 stars in a row, and it's to the left of them. And in my image, of course, tilted a little bit, 3 stars in a row, and right over here is another globular cluster. Let's zoom out actually and find some other bright globular clusters. We'll zoom out both of these images. Now, this bright star over here, this is a bright foreground star in our own galaxy. It just happens to, by coincidence, be in position in front of the Andromeda galaxy. This star is one that I recognize very well. I often look at it through my own telescopes visually because I use this star as a waypoint star to try to visually find one of those globular clusters in the Andromeda galaxy. And this one is fairly bright. This one is called G279. And here is a chart of some of the globular clusters in the Andromeda galaxy that I found on cloudy nights. And this right over here, where my magnifying glass is on the right, is that bright star that we were looking at. And right over here, this is where G279 is, but it's not labeled in this particular chart, but that is the one. And if I look at this chart over here showing the magnitudes of the various clusters, G279 at this position is magnitude 15.4, so it is very, very faint. And I was trying to look at it through my 12.5-inch telescope, and I really struggled, and the moon was coming up at the time. So I'm going to try again from a darker sky with my 16-inch telescope, and it should just be doable. But in the images, it should be very easily visible. So this is the bright star. Above the bright star, there are these two stars diagonally in a row. And right in the center of these two stars is the globular cluster G279, one of my favorites because it's so easy to find. It's right above this bright star and in between these two stars. Now, in the Hubble image, it is fairly well resolved. You can see lots of little stars in there. So if I pull up my own image, this is the bright star right over here. These are the two stars diagonal that are visible over here in the Hubble image. And right in between these two stars, you can see this large fuzzy patch. And again, it's not resolved in my image because it's in the Andromeda galaxy 2.5 billion light years away. But you can clearly see it looks fuzzier than these two bright stars around it. So that is G279, a bright globular cluster in the Andromeda galaxy. And just underneath it in the Hubble image, you can see this faint little star. I'll zoom in right there. And that very faint little star is also visible in my own image over here. Quite remarkable. Still blows my mind. And now if we zoom out on the Hubble image and we go further up a little bit, just to give you some context, this is where we are in the Hubble image. There are a couple of bright stars in this region. So there are these two bright stars, and right above them, there are these two large patches that do not look like stars. They don't have, again, those diffraction spikes around them. So if I zoom into each of them, in the Hubble image, they are resolved as globular clusters. You can see some of the stars in there. And same with the one down here. You can see some fuzzy stars in there, just barely resolved, but they are resolved. Now, if I move to my own image and I try to find both of these stars, let's see if I can. So they are kind of parallel to this large region of gas and dust. That's the region of gas and dust there. These are the two bright stars here. That's one, that's two. So I zoom in a little bit more there, and I will match that same region around the same size with the Hubble image. So number 2 and number 1. There we go. Okay. I think I'm looking at the correct region. Yep. So this is the bright star number 1 in the Hubble image. Right above it is this large yellow patch, which is the globular cluster, and above it is a bright yellow star. So in my image, this is star number 1. This is that bright fuzzy patch right here, which is that one in the Hubble image. And again, it looks fairly fuzzy, a bit fuzzier than the other stars. So you can tell that is the globular cluster. And above it is this very yellow star. Again, this one in the Hubble image. It's a yellow supergiant, very likely in the Andromeda galaxy. It's not a foreground star. And if we look above and to the right at roughly maybe the 1 o'clock position in the Hubble image to this, you see this bright background galaxy. It's very, very yellow. So its light is, a lot of it is likely being absorbed by the foreground Andromeda galaxy here, which is probably why it looks so red. The light is being extinguished by the gas and dust in the Andromeda galaxy. And in my image, right over here, you see that same galaxy, same shape, same bright nucleus, And this is again a galaxy in the background of the Andromeda galaxy, and you are seeing this galaxy through all the gas and dust in the Andromeda galaxy. So in reality, it's probably a bit brighter than it looks here, but again, a very small background galaxy. And I can't even hazard a guess as to what the magnitude of that would be. But if we were guessing, this globular cluster over here is magnitude 15.4. So this galaxy must be, if I was guessing, at least maybe magnitude 17 or so. So quite a faint background one. And then there was another globular cluster. So above this second star here, that is again a large fuzzy one, very, very bright. I think that's G280. I could be wrong about that, but quite bright and fairly well resolved in the Hubble image. And there it is, this bright patch in my image. If I zoom into a ridiculous level, this is 345% zoomed in my image, so it's too far, but you can definitely see this bright patch and this blue star up and to the left. That is this blue star here in my image. Now, just nearby, there is this very large region of hydrogen gas in my image with a bright star cluster in its core. And that's a star cluster in the Andromeda galaxy. Let's see if we can find that in the Hubble image. Now we'll do some star hopping. This is the bright star in the Hubble image down here. So above it is this globular cluster. To the right is this bright region of gas. In my image, again, this is the same star. Up and to the left is the globular cluster. And to the right, this here is the same cluster that's visible in the Hubble image. So you can see that these are individual stars, individual very, very bright stars. The ones at the edges are resolved in the Hubble image, but the ones in the center are not. Again, same thing. You can see the edge ones resolved in my image, but not the center ones. And in my image, you will notice that there is this giant cloud of hydrogen gas, this glowing red cloud, this nebula around these stars, which you cannot see in the Hubble image. That's because the Hubble image is just in regular visible light, but the Hubble team did not use a hydrogen alpha filter. So in the Hubble image, you can see this faint glowing fuzz around the cluster, slightly bluish. But that's the nebula. So my image went a lot longer. I spent 28 hours in this region, whereas the Hubble took a lot of much shorter exposures, thousands of times, to cover that entire part of the galaxy because of its much smaller field of view. So that's why you can't see all the glowing gas in the Hubble image around the cluster, but you can see the cluster in both of those images. So again, individual stars in another galaxy. And just think about how crazy that is. Now let's look at some other interesting things. Now, one of my favorite things to look at in the Andromeda galaxy, and this is something I've never been able to do visually, at least not yet, but with the new 32-inch telescope that the Royal Astronomical Society has, I think I might have a shot at it someday. But this is a star in the Andromeda galaxy called Cepheid Variable V1. And I will pull up a Hubble article on the star. This is the one over here on the right side. So on the right side in the background is a professional image taken by R. Gendler. And on the right, you can see a cutout from that's more zoomed in. So this is an old photographic plate of a particular star in the Andromeda galaxy, taken by the famous Edwin Hubble, who the Hubble Space Telescope is named after. Now, just a quick background. Before about the 1920s, people would look at these galaxies and all of these distant galaxies like M51 and M31, the Andromeda galaxy, and they called them spiral nebulae. They thought that all of these galaxies were just nebulae within our own galaxy and that they were fairly small and fairly close by. And in 1912, Henrietta Swan-Leavitt discovered a relationship between a particular star, a Cepheid variable star's pulsation period and its true brightness. And she had noted that the longer a Cepheid variable star's pulsation period, the brighter it appeared to be. And in 1923, Edwin Hubble began taking some images of Messier 31 of the Andromeda galaxy, just like I did, and countless other amateurs have. And he was using the 100-inch Hooker telescope, which at the time was the largest in the world. And this on the right here, this black and white image, is one of the images that Edwin Hubble took of this galaxy. And he noticed while imaging this over a period that a particular star in this galaxy was pulsating in brightness over a period of about 1 month. And he made some notes. He drew these two lines, and right in the center of the lines was that pulsating star that he had seen. I will zoom in further here so you can see it in case you're using a small monitor. So these are the lines that Hubble had drawn, and right in the center there was a pulsating star. And initially he thought this was just a nova that would go away, but after observing it over a period of time, he noticed that it was not going away. It was just pulsating over a period of about 1 month. And using the period luminosity relationship that Henrietta Swan-Leavitt had discovered earlier, Hubble realized that if this star was a Cepheid variable star, like those in our galaxy, it would have to have an absolute magnitude of -5. And then he calculated that for a Cepheid variable star of this brightness to show an apparent magnitude of 18.5, which is the magnitude of this little star, it would have to be nearly 1 million light years away. And of course, this was a bit off from the actual 2.5 million light year distance that we know the Andromeda galaxy is at now. It was far enough away that Hubble realized that the Andromeda galaxy is an entirely different galaxy, and it's not a little spiral nebula within our own galaxy. And from that, he also realized that all the other galaxies that we see, such as the Whirlpool galaxy and the Bode's Nebula and all of these galaxies, are all separate galaxies far, far away, millions of light years away. And he realized that the universe is much, much bigger than anybody had thought. Now, this little star, imaging this star was one of my goals as well, and I also hope in the future to replicate Hubble's findings by taking a time lapse of this star over a period of about a month and measuring the change in its brightness, in its luminosity, so I can redo the calculations that Hubble at the time had used to determine the distance to the Andromeda galaxy and therefore the size of our universe. So then the Hubble Space Telescope actually imaged this star later on. And in the Hubble image, let me see if I can zoom in enough. There, this is that star, Cepheid variable V1, magnitude 18.5, this in the circle here. And a close-up view from the Hubble of that star. Hubble took a time lapse of the star. This was December 17, 2010. And this was December 21, 2010, December 30, and January 26. And you can see that the star dimmed in brightness a little bit over here and then got brighter over here. Now, it's an individual star in the Andromeda galaxy, and a very faint one at that, so it just looks like a regular star even in the Hubble image. Now, if you're wondering what it looks like in my image, of course, it's not going to look as bright as the Hubble Space Telescope because, it's my little backyard telescope. But this is how I find this star. If you're trying to find it in your own image, here's the easiest way to do it. This is the bright small galaxy orbiting the Andromeda galaxy. If you come straight down from it, you will notice these two hydrogen alpha regions. And to the left of them is this bright region of stars, if you can see the hydrogen alpha regions in your image. And they are in this lower, let me make this larger, they are in this lower belt, I guess, of gas and dust. And right in between these two, there is this bright cluster of stars that I'm going to zoom in my image, and I think these are individual stars in the Andromeda galaxy in this cluster as well. We can confirm by comparing it to the Hubble image later on. And right above and to the right, there is this V-shaped structure. There's this V-shaped asterism of stars. And if we look at this earlier professional image, you can see a little V right over here. So in this image, it's an upright V, like properly oriented. And if we look at the image over here taken by Edwin Hubble, it's in the same orientation there. It's an upside down V in this image. So there's the bright star. There are a couple of fainter stars going upwards. That's the last star. There is this star, which was Cepheid variable V1, and then there are some other stars over here. Now, if we look at this professional image in the background, actually, let me see if the other one offers a better view. There we go. So this image over here, again, doesn't show it very well. I'll try to zoom in more if I can. Okay, there we go. So in this image, yeah, zooming is not going to help. What you can hopefully see on the screen is this upside down V. So there is this bright star over here, then star number 2, which is a yellowish star, 3, 4, 5. Number 5 is that Cepheid variable V1 star, and then number 6 and 7. So number 5 in this upside down V is Cepheid variable V1. Now if we go to my image, make that larger, we will find the same structure. And right over here, this is that structure in my image. This is the bright star that was showing, and in my image actually it's an upright V, not upside down, just because of how my camera was oriented. But this is the first bright star. This was the second yellow star that we saw from that professional observatory image. Star number 3, star number 4, star number 5. This is Cepheid variable V1, and then number 6 and number 7. So, of course, I can't see much detail on this star, and it's not super clear because this is a very, very faint magnitude 18.5 star. And at the time I imaged it, actually, I think it was probably a little bit fainter. It seems to be a bit fainter than the star next to it, which was not the case in Edwin Hubble's image. But yeah, I'm just going to zoom into a ridiculous level so you can see it, but it is fairly well visible. I mean, I think it's bright enough to, with enough data to perhaps get a spectrum of this star as well, which would be quite amazing to get a spectrum of a star in another galaxy. And yeah, so this is what Cepheid variable V1 looks like in my image, which is quite amazing. And this is what it looks like in the Hubble image right over here. I hope you found that as exciting as I do. I mean, it's not much to look at, but the important thing is just to know what it is that we are looking at. We are looking at an individual star in another galaxy, and that just blows my mind. There are countless other globular clusters here just spread out all over the galaxy, and you can likely see close to about 300 different individual clusters in this galaxy. And actually, if we look for some really faint objects, let me just pull them up here. Okay, here we go. So this is an image from the Hubble that I absolutely love because it is zooming in on this region of the Hubble image that's in the box. And if we look down here on the left, you can see that in this region, there are a couple of very faint globular clusters in the Andromeda galaxy. And on the right, you can see them at the maximum size from the Hubble Space Telescope, and they are resolved. You can see individual stars in those clusters, very much like, amateurs like me normally see individual stars in clusters like the Hercules cluster in our own galaxy. But the Hubble is able to resolve all of these clusters, these very faint clusters in the Andromeda. And I was curious to see if I could find these very faint clusters in my image. It would be a challenge because these are going to be extremely faint. I don't know what the magnitude would be, but I will try to find out. If I had to estimate, probably looking at about magnitude, 17, 18, 19, something around there. They're extremely faint. So let's pull up my image on the side and see if we can find that same region. Now, looking at the Hubble Space Telescope image at the top right, what I'm noticing is that, again, this dark structure from the Hubble image, which is, let me zoom in, this one over here, this is visible right over here in my image. So as you can see, exact same structure here and in my image. The Hubble has better contrast, of course. And if we move to the right, all the way to the right, there is another large dark structure of gas and dust. That is this one in my image. And we go a little bit further, and we can see this little L shape here in my image, and I found that in the Hubble image as well, right over here. This is the little L shape that I captured in my image, right over here. Now what I'm noticing is that right underneath the L is a bright star. That is this star in my image. Now we're going to zoom in on this box in the Hubble image, and just remember this little L, this dark L lane of dust and gas right over here. Now this is all of that region, just more zoomed in, and I'll zoom in a little bit. Let me see if I can zoom in better. There we go. So this is the full size available there. There we go. So this now, where my mouse is, my little lens on the screen, this is the L structure in the Hubble image, very clearly visible in my image as well as an L. They're roughly at about the same size. And this is the bright star in the Hubble image. There it is in my image. Right above that is another bright star, and that's right over here in my image. So we've established that we are looking at the same region. And again, this bright red cloud of hydrogen gas in my image is because I also used a hydrogen alpha filter along with the RGB filters that the Hubble used, or the equivalent of. Now the first one we can try to find is AP14. So to find AP14, basically what we do is center of the cluster to this bright star and then straight back. We just do some star hopping. So if we do that over here, center of the cluster to the bright star and then right back, right over here, that is AP14. So it is visible in my image, but of course very faint, and I can't make out any structure like I could on some of those brighter globular clusters. And just to the back of it appears to be this one over here. And I think, yep, that right over there, that blue area where I'm rotating, or just above my hand on the left, is AP94. And then there are these two down here, AP6 and AP323. Those would be a challenge to find, but I think we can find them. So they are... I think they are, let's see, we'll have to do some more star hopping. So center of the cluster to this bright star, form a line to this bright star, and then to the left is another bright star. So if we do that from here to the cluster, so there is this bright star over here, and then to the right there are these two little stars. If we come up, another star, and okay, they're a little bit further right than I thought. I think this over here, oh yeah, there it is. So this top one over here is AP6, bottom one is AP323, and right underneath is a bright yellow star. And in the Hubble image, you see the yellow star right over here as well. So extremely faint clusters, but they are visible in my image. Let's look at AP323, which is this little fuzzball right over here in my image, just above this yellow star. And let's get a close-up AP323. There it is. So yellow star, and there is the cluster. Again, doesn't look like much in the Hubble image either, but I mean, just the fact that I can capture it with an 8-inch telescope from my backyard, absolutely mind-blowing. And then right at the very top of this image is, in the Hubble image, is AP108. And to try to find that, I'll see if I can find that in my image. That will be a bit of a challenge. So this L-shaped structure, if we follow the bottom of it, goes right to AP108. So if we do that with my image, this structure goes to, let's see if we can find it. This is going to be a bit more challenging than I thought. So this structure points to another dark lobe over here. So this structure, that's, yeah, I think that's the lobe over there. And I think that might actually be cut off in my image. I think that region might be cut off in my image, so I don't think, yeah, I can't reach that. That's way too far up there. But yeah, we were able to see a couple of these clusters, and I wonder if we can see any of these background galaxies, maybe just get a faint hint of them. I mean, they're so faint even in the Hubble image that I don't think there's much of a chance of me being able to see them, but I mean, our track record so far has been pretty decent. So these are the two AP14 and AP94 clusters that we had looked at earlier. And right behind, let's see if we can find any bright star to use as a reference. So what we could do, so this dark structure in the Hubble image points roughly at these galaxies. So if we follow this structure, this region over here roughly is where the galaxies are going to be. I cannot be 100% sure. Oh, no, I think I might. Yeah, I can't be sure. We're getting to... I mean, I see this yellow fuzzball over here, which looks like it's this fuzzball, and there's a star right in front of it, which could be this little star over here. But yeah, at this point, I can't be 100% confident. I mean, those galaxies are so faint and in the background and blocked by all the dust and gas that even the Hubble's having trouble seeing them. So basically, this shows that with enough exposure time, I mean, you're never going to reach the resolution of the Hubble from the ground ever. But if the Hubble didn't spend that much time on each region, it's just trying to use its resolution instead of exposure time. With a crazy amount of exposure time, you can actually get some interesting images where you can see some of those very faint structures or background galaxies or globular clusters from the Hubble images in your own images. So that is quite amazing. So I hope you enjoyed this as much as I did. And yeah, join me next time for another comparison like this. And if you like my image and you want to get a print of this amazingly high resolution, high quality image, you can check out my Shopify store. I have uploaded this image there as well, and the link is in the description below. And of course, the only reason I started a Shopify store was because I plan to donate 100% of everything I make from the Shopify stores to the people in my village. And you can get the details about all of my projects on the side that I do, following the link in the description below about that as well. So again, thank you so much for watching. If you made it to the end, I really appreciate it. And consider hitting the subscribe button if you found my content helpful. I will also be posting a lot of tutorial videos showing you how to make amazing images like this with fairly basic equipment and how to process them. So make sure you subscribe to the channel so that you're notified when I post some videos. And I'll be sharing all of my best tips and tricks about how to process images like this for all skill levels. And if you know a friend who is also interested in astronomy, feel free to recommend my channel to them. So if you want to see more of my images, you can follow me on Facebook at The Real Amateur Astro as well. I tend to post images a lot more often there than I do on YouTube. I mainly use YouTube to share tutorials and tips and tricks, and I occasionally live stream as well, but I will be doing a lot more live streaming now that I have a color camera. Thank you very much for watching, and clear skies.